Hello, this video is to show the unboxing and assembly of an E3D V6 printer hot end, and also the unboxing and display at least of the Hemera bowden extruder to go with it. These are for my tool changing printer I've been working on, the Frankentron. It started out as a Tronxy X5SA Pro and is now rather different. That's detailed in another video. And part of that is extra tool heads. Get rid of the packing material. Leave the extruder on one side for now. And to start with, concentrate on the print head, the hot end should I say. Now the E3D kits, I've had a couple of different ones before, and they do tend to be very nice. Everything's organised in individual bags, they're labelled up with what they are, what they relate to. You get all the specific screws, even some of them colour coded black or silver. As you can see, it's all the heater block, heatsink, that's the actual V6 stuff. And I can get the bag apart. Okay, there it is. Heater thermocouple or Thermistor, fan shroud, fan and silicone boot in that one, and the heatsink, heater block, heat brake and nozzle, and one or two other bits, screws for it in that one. Now, if you do one of these, they require you to print some parts before you start, which I already have done. That's the fan mount for the Toolchanger. There's the top adapter and cable bracket, and a fan duct. That's the part fan. So anyway, to start the assembly, I've already given these a rough clean up, but the first thing you have to do from the instructions is tap the holes in the face of that 2.5mm 2.5 thread. I'll get the box out of the way. I have a little file here just to give it a quick deburr. I've opened the holes out already to 2mm with a drill bit and cleaned these through at 3mm, I think, ready for either the clearance or threading. Sorry, 2mm for those, for tapping out to 2.5, 3mm for those, for attachment. Now, I don't have an M2.5 tap, so I've made a very crude one when I find the right bit. Now, I don't know how well you'll be able to see this. You can get it to focus. It's just an M2.5 screw. It's been partly filed to a taper at the end, and also using the edge of a half round file I've put some grooves along the length. So I'll basically hold it in pliers like that and just groove it lengthways to give it some at least very short cutting flutes, which hopefully will work as a tap and cut a thread. So I'm going to try that now. I'm afraid you're looking straight up of it, but I just want to get the screw started square into the hole before I turn. That does actually feel like it's cutting. One of the things with PLA, which this is, it should really be, that's supposed to be a harder material. And I did not clean those out properly first. I thought I had, but I lost track of what bits of preparation I've done. I'll just clean that out first and try again. So just put an M2 drill through that. As I was saying, one of the things with PLA is if you try and drill it or tap it very quickly, the friction tends to heat up the metal drill or tap and melt the plastic around it, which when you're trying to drill can be messy because it just starts to drag everywhere. But for tapping, especially with something like this, it can actually be useful because once you go through to the clear part of the thread, you leave it a few seconds to cool and it moulds its own thread back around the screw. And get that started again. I can't even find the hole in it. Try again. That's better. That's now through to the clean part of the thread. So those three to tap, which will later have the part cooling fan attached on its duct, and the other two attach it to the angle bracket that supports the hot end on the tool change plate. And that was through. And that one, I lost track of which ones are done. It's that one that needs doing next. That's the 3 2.5 ones done, which are the awkward ones for me because I don't have any proper thread cutting equipment for 2.5mm. And also for the tool change version, the little hole in the side of the cable bracket is supposed to be tapped M3 to take the grub screw that holds the metal strip cable support in. Now, this is my preferred way of doing an M3 in this material. It's a tap-tight screw. They're quite often supplied such as metal die-cast boxes. It looks like a standard metric screw at a distance, and when you take it out, a normal metric screw fits. But the end is just slightly tapered over the last few millimetres, and it's a kind of rounded triangular profile, and it rolls a thread rather than cutting a thread. So ideally the hole size should be about halfway between the clearance diameter and the normal tapping diameter of the screw. But if you put it in and take it out again in a normal material, you can then put a normal metric screw in afterwards, or you leave them in if that's the type of screw you need. We use a lot of these in larger sizes, typically M4, M5, for attaching control equipment in machine cabinets. It's a lot quicker than having to drill and tap each individual hole. Just put the appropriate size drill through, drive the screw straight in with a power driver, and the job's done. And it's got a perfect thread. If anything's removed, it can have standard screws back in it. Now, as I'd forgotten to clean the other screws out on that one, I will just check those and I'll clear at 3mm for later on. No, they weren't. Not a lot of material to come out, but just enough so it's worth doing to make it easy to get the screws in. Whilst I'm on that, these also should be 3mm. Some long screws go vertically through this assembly. To attach this to the tool bracket and the tool change version. And I just realised you probably can't hear what I was saying once I got the drill running. Sorry about that. Yeah, there are some long 3mm screws go through this and into the tool changer bracket for the tool changer version of this tool, and something similar on any of the other, the Hemera direct drive or any other tool changer tool for the E3D system. Okay, put those on one side. Just get rid of the dust. I'll put in the full later. Right, on with the actual assembly. Now I've got the bracket ready. For this tool, it also needs the tool changer bracket doing. So you can skip this if you are not doing the tool change version. Thanks. Symmetrical at the top. You can't tell which way is which, so I'm just going to tear it. That's the tool bracket that attaches and releases from the tool changer system on the machine carriage. That is the mount that goes on the machine body. And the bit I've got to attach first is that which goes on there. Find the appropriate bits to go with it. There. Very ingenious system. I'm going to say sneaky, which in a way it is. It's not devious, it's just genius. Little magnet that fits in the static side on the bed. That needs gluing in, and there's a couple of dowel pins to go in that as well, which I'll just screw in by hand though. They do need loctiting really, thread lock. But just to demonstrate the tool change mechanism. This part mounts with the pins horizontal on machine frame, either directly or through some kind of adapter depending on the machine. On mine it goes on a printed adapter like that, as the heights are completely different to the original E3D machine, so it's offset in and up a bit. Let me just put this together. The magnet that fits in the fixed part and that little black grub screw that fit in that part are a bit of the genius work. Yeah, that's the size I need for that. Now, several of these bits really want thread lock or Loctite on them, some equivalent. Now, a little trick I use when I'm working on small items where you don't want to put a full drop on each part, you just want a tiny amount. Just put a couple of drops on a bit of waste plastic, and then you can dip into that either the screw end or a bit of wire to transfer it. There's no wire offcut. So you get a more appropriate amount without keep wasting it. Now, these even come with a little kit, the smaller size Allen keys in, the hex keys. I'll use one of those. So again, this is only needed for the tool change version. That black bracket with the cutout there and downwards fits on the main tool mounting plate. Just dipping the screws in loctite so nothing comes loose in future or without it being deliberately dismantled. So that's the basis of all the E3D tools. The carrier part. And that lives on the frame and just slides on. At the moment there's nothing to hold it. And I should have put that in first, I'll get carried away. We'll just remove that before the Loctite starts to go off. More thinking about demonstrating it and actually building it properly. Just leave that balanced on something for a second. Okay, as I was saying, before I distracted myself, a little black screw goes through there, threads into the back side of the tool mount. That needs to be set flush somehow, also at least so it's not protruding. It's about there. Then the whole unit fixes onto the plate. I'll just refresh the Loctite on the screws. A bit of wire. Make sure it's still there. And it hasn't started to cure. Right. Try again. I was saying, that little aluminium piece has a steel screw set in the back of it. That aluminium piece has a magnet set in the middle of it, so when the tool changer releases on the frame, the tool is held quite solidly in place. The tool changer picks it up, it just pulls it clear, and it's ready to use. There's no mechanical attachment as such between the tool and the carrier, the frame side holder. It's just that guide pins and the magnet. Anyway, back to the tool assembly. That bit's ready for use when it's needed. So after that, going back to the instructions. Right, the next stage is the mounting bracket and the fan bracket. Now this has to fit on the top of the mounting bracket. That's quite a square edge there, so just check that's clean in those faces. the holes will line up. So then it wants 2 of the short M3 screws, a cap head style, to hold it on. That's that one. Dip in Loctite. Just put that part way. I won't tighten until they're both in. Makes it a bit easier to fit if everything's loose until all the screws are in usually. If you're doing a multi-screw part. Nip those up. And now we get to the actual hot end assembly. I have a heatsink, a retaining nut for it. Depending if it's a different type, it may be in a clip rather than a nut. The heat break, the heater block, the heatsink compound, thermal grease, and the heater, thermocouple and fan. I'll get all these bits out, so I'm not fighting bags again later on. Not enough of that. So, according to the instructions, you're supposed to attach that there, then assemble the heat break and nozzle and fit them into there. Now, last time I did one of these, I tightened that all really solidly first, then screwed all this lot in, and ended up with the heater block in totally the wrong position. So I'm not going to tighten that yet or put in any locking compound on it until I've got the heater block attached and in place. So I've got the little bag of thermal compound there, transfer compound. Just open that up ready as well. Try not to dip things in the Loctite unnecessarily. Right, now this is one of the critical bits, and the very first time I assembled a hot end I got this wrong and wondered why it didn't work very well. If you've done these before, you probably know, and I'm wasting my breath, but if you've not done one before, the heat break doesn't screw in all the way. It only screws in until the bottom half up to the neck is flush. So hopefully you can see it at that. So that's now flush. The start of the neck is level with the top of the heater block. Then put the nozzle in. Just nip that up a bit. Doesn't have to be particularly tight. It's just enough to hold things in place. Then put some thermal grease on the upper half of the heat break. Get carried away there possibly, but it won't hurt. I'm concentrating more on the top because most of it's going to get pushed down as I screw it in. It's just going to build up on the threads and move down anyway, so it doesn't need any extra on the bottom. But there's a little bit too much there, like I said, but it'll do. If you look at that now, hopefully you can see the neck is visible below the heatsink. But if I remove a bit of the mess, hopefully it'll be clear. You see the neck, top and bottom surfaces line up pretty accurately with the heatsink and the heater block. Now everything can be tightened up quite solidly. Don't use any extra tools, but by hand, pretty tight. You don't want to risk damaging the neck though, because that is quite fragile. I mean, it's not exactly brittle, but it will break or bend if you put enough force on it. You don't want to strain it. And as before, that ended up half a turn out from where I wanted it. So now I know where that's going to go. I'm going to put a small amount of thread lock on there again. Now I'm not putting it actually on the thread because I don't want to lock the nut in place. This is to stop the heatsink turning in the bracket just due to vibration or general pulling with the cables and stuff later on. So all I'm doing is putting it against the bottom flange that will tighten against the bottom of the bracket. That should hold it nicely and prevent any movement without making it difficult to dismantle later on if needed. So it's just got a nice little ring of locking compound on the bottom of the bracket, but not any amount on the thread itself, so the nut won't be retained. And that is supposed to assemble that way around on this one, I believe. I've got the instructions on the computer at the side of me. Yes, for this assembly, the heater block should face away from the fan bracket. Just give that a gentle nip to hold it in place. With oversized pliers just because they don't round the corners so much. So that's the heater block in place on the heatsink with the heat break. That is the fundamental assembly for the V6 hot end. Now this is a bowden feed one, so there's also a little collet to go in the top, which actually looks very much like a lead panel clip, but I suppose it is the proper thing, unless they happen to be the same size. Could be. And a little retaining clip which can be taken off to put the feed tube in, but I'll keep it there to now. It stops everything flopping about and stops anything getting lost. Now the fan assembly is next. I won't actually be using this one on mine, as I'm using the E3D Tool boards, little CANBUS connected boards for each tool head, which have connections for all the fans, the heater, stepper, the extruder stepper, temperature sensor, and a few other spare IOs, and only need a power and a CANBUS link back to the control board. But the version I have only has 12 volt out for the fan, even though the system is 24 volts. The latest version out has 24 volt option by link for the fan, but mine doesn't. So I've to swap these for 12 volt fans. But as this is about the assembly rather than modifications, I'll stick to these for now. That's what I'm looking for. So the fan is held on the heatsink with self-tapping screws, which have a number 1 positive drive head. sorry, the heatsink adapter fan duct, I say. Should have 4 in it. I'm only going to put 2 in. In fact, I only used 2 in the example. Only 2 screws with it. Well, it's got positions for 4. It doesn't need all 4. I will be swapping that for a 12-volt one before it gets powered up on the machine. And the fan duct clips on, so the top and bottom are level with the top and bottom fins, like so. So that's the heatsink cooling fan. Now the various wires should thread through on this one, fit through the cutout in the block there, the mounting block. And the connectors are in the casing above that. The next things are the thermocouple, or thermistor, and the heater. It doesn't say anything in the instructions about putting heat transfer compound on these, heatsink compound, but I don't think it hurts just to put a tiny amount on, don't need much. Position that in there and put a black pointed grub screw in. It's about central. That just needs very gently nipping in, just enough to stop it vibrating, but without crushing it. It'd be very easy to crush that. And the same for the heater, just a trace of that on it, just to help it make good contact. So that's about central on these little black button head screws. And that's not a grub screw, it's a pinch bolt. It actually squashes the heatsink slightly where it's got the cut it. So it fits around that, and something's just turned on there, I think. Oh, it doesn't, it's the fan turning. So that's the basic assembly of those. Again, that's got to go up through the bracket on this one. Thermistor, for some reason you're supposed to leave that out of the way for now. So I think that's moved a bit. I'll have to slip with that. That's gone a bit further through than I'd like. It should be more centralised. About a couple of mil either side of the heater body. So now that, I believe, attaches to the Toolchanger bracket on this one. If you were doing a normal fixed head, then you would use whatever bracket is supplied or needs to be printed or whatever for your particular tool head. And that attaches there to the middle 2 holes, and from the side of the metal bracket that supports the heatsink to the middle 2 holes on the tool adapter plate. That needs another 2 M3 by 8 countersunk screws. Loctite as before. Get that round into the right angle. It's quite a tight fit against the top of the fan bracket. That's it. It's got both of those in. Bit off-putting where this wobbles. You keep thinking something's moving, or I do. Or something is loose that shouldn't be. It's just that is purely a clip-on piece that can swivel. Right, so that's the key's not very good. All the screws aren't very good. Anyway, they're tight. That's the hot end mounted very solidly all the way through to the Toolchanger bracket. Now the next thing is the workpiece cooling fan. That has a little printed bracket which needs to attach to the fan. Now the slots in it just need a little bit of cleaning out. That needs a needle file. The slots aren't quite big enough the way it's come out to fit around the thin lugs on the corner of the fan. That's it. Just run a file through those and give them a quick clean. Well, they're tight. I can't work on them easily under the camera, bring it forward like that. That's the go. Yeah, they're quite tight. Oh, there we go. That's time to clean up now. It's out to the thickness of the file, see how that goes. Yeah. Right. They're okay now. Width-wise, space between them is just a fraction too small. The fan won't quite fit in. But there are some little burrs in there now. Partly from filing, partly just stray bits from printing. So just clean those up on the inside as well. Just make sure that camera's still running. I've not forgotten to clear the memory. Okay, that's almost there but not quite. Yeah, that's just right now, just a snug fit. As long as the screw holes line up. Now we just clean it down a little bit more. again. That's it. There's now a minimal gap through there, and it looks like I can see straight through the screw holes. Now, I've not cleaned those out yet. They need to be out to 2.5 millimeters for the fixing screws to go through. I'll just run a 2.5 mil drill through those to make sure they are okay. And very slowly so I don't heat it up. I compared this fan to the 12 volt ones I got a batch of earlier on this project, and unfortunately the other fans are slightly different. These have got a very, very thin ear tab with quite a big space underneath. The other fans have got that much thicker. It's almost down to the bottom surface of the fan. So when I swap the fan, I'm actually going to have to chop the bottom half of that channel fork off, I think, and the screws will only go through the top. And just clamp that and the fan down together without that little piece underneath the bottom ears. It doesn't matter, it will be attached solidly, and also there is an additional screw into there. Now that's something else. That needs tapping. It doesn't say anything about the instructions, but it's going to have a screw in it, so it needs tapping. Where's that tap tight screw? Okay, there it is. Typical, I'd think I'd finish with it and put it somewhere and forget where I put it. Right, so I need to run that 2.5 mil drill through there as well to start with, just to prepare the thread. I'll prepare it for the thread, should I say. And give it the right clearance for cutting the thread. Then just put this screw in it. That's it. Driving this in fairly fast, quite a bit of force, which will make the screw heat up and soften the plastic as it goes. I feel it's kind of oozing now. Hopefully the plastic, the heat will dissipate through the plastic. There's a lot less friction taking it out. I'm doing it rather slower. I'll leave a nice moulded in thread. That's quite long. Okay, just to clean the face of that for any burrs. So that assembles to the opening of the fan. And fits there. There are 3 2.5mm screws in the kit. 2 one length and 1 slightly shorter. So roughly 8mm and 6mm, I guess. The 8mm ones go through the positions where the duct is stacked on it, and the shorter one goes only through the top here on the fan. This one's going through, this is the longer one going through both the duct and the fan. And that should hopefully go into the hole I tapped into that fan bracket earlier, but it's not doing. Position is not quite right at the moment. Just get that in line. Just leave it at a slight angle. Make it easier to get in place until that wants it into part it. Then I can twist it across into the correct line. And hopefully the other two will go in without too much difficulty. Oh, that's that one in place. That one just needs pulling in a bit now. And the gap at the top's closed up nicely. So, with a bit of luck, that one will also go in. Looks like it's a fraction out, but I might just have to slacken these a bit to allow it to line up. Oh, fraction out, it looks a long way out, I don't know how. And the screw is very tight in, it's starting to go. Start out being quite tight in the fan. I think now I can twist it a bit and just persuade it to get into line. That's why that's been awkward. Normally, when I've assembled these printed parts, they've gone near enough perfectly. I might have pulled something when I was drilling it, not got the hole quite right. It is in. Just took a bit of gentle persuasion. Don't overdo it and crack things. Select them all again, because the 3mm one is out of line slightly. See, with those slightly loose, I think I can get that one. That has another of the 8mm and 3 countersunk screws in it. A little bit of loctite, and hopefully I can persuade that to go into there. That's it. And the Allen keys aren't very good quality, or the screws aren't very good quality. I don't know which is probably the Allen keys. Don't fit very well in the countersunk heads that got very shallow recesses. Okay. Right, now for the tool change version, the next parts will be the little spacer bracket and the cable support. But before I fit those, I need to make the cables up, so that's as far as I can go in this video, really. Just get that one out of the way for a bit. Just to demonstrate how I thought I'd not assembled that yet. I just will do that. And a little bit of locking compound, thread lock, loctite on the screw, and just slightly onto the body, because the counterboard holes and the parallel part of these pins fits in 3 or 4 millimeters. So the loctite on the shaft of the thing is doing some good. And you can use a small Allen key as a Tommy bar just to give them a gentle nip up through the holes provided. And the magnet goes in the back there. You can use a bit of wire to pick up loctite from my piece of plastic and transfer that in. They're not a tight fit in these. We've done a couple of the brackets already, so be quite generous with this. I would. I mean, the instructions say use super glue, something you could do, but I've got loctite out. Loctite is very effective on new and unparalleled fittings like this, so I'm happy using that. So that's the assembly for that, and when everything's fitted in the machine, I'll just give that a wipe down so it doesn't get the loctite into the guide holes in the tool mount. And the magnet dropped out. Okay, try again. So when that's on the machine, the tool will go to the frame like that, or when the tool changer comes in, the locking pin will just turn on the little ramp on the back of that plate, attach the tool to the carriage and take it away from the pins. Leaving that on there means the magnet's being pulled hard against the end of the bore in that, which has just a tiny fraction mil lip, and that makes sure it stays in place while the loctite set, so I'll leave that like that. There's also the boot there to go on. I'll put that on. Our silicone boot. Now, for my machine, the tool changer mounts don't actually fit directly to the frame as they do in the E3D design, because it's a retrofit. I'll have to take that off again. They go onto these printed adapters, and then the cable mount part fits on top of that. And that the cable adapters with these, by the way, both for the top of the tool and for the machine body. Very neat design. They've got holes through to take cable ties, which aren't very obvious, but they are there. I have to move up a bit probably to see them. See the holes there for cable ties and matching channels inside. A slot through which has a metal strip fitted in, a long springy metal strip from end to end, which supports the cables in an arch so they don't sag in the middle or drag on in other things. That's the frame side again. That's got the holes through for the cable ties and the slot for the metal strip. Then there's a little grub screw that goes in the back of each that locks the metal strip in place. Very neat system. You just get a nice clean curve of the cables from the tool to the frame as it the whole thing's flexible, so they move about as needed when the tool's fitted or in use. But that part attaches to the top of the metal bracket, and an E3D version it clamps straight to the frame. On mine it goes through to the adapter. And those screws are for the those are for attaching the top body and cable bracket to the top of the tool. These two are the ones for the dock part. There's two attachments and a grub screw for the metal strip retainer. So we'll just do these. Although I'm not clear those. The 3mm drill running through. Another one of those, they all do at the same time. There are two versions of these in the E3D Toolchanger files in mirror images. The extension is intended to hold the bowden tube on a bowden head, or the feed tube on a direct head. And the mirror image, that can be either side depending on what suits the arrangement best. So hopefully now I've cleaned those. The screws should go through. That's better. The screws go through now. And I've printed these with cutouts that allow an M3 nut to be fitted in to line up with the fixing holes there. So they are structurally strong rather than just tapping screws in. I found if it's something you're working on, you keep taking screws in and out, the threads don't stay in good condition for all that long on this material. Now actually, I'm not sure if, yes, that screw is just long enough. I've used 30mm screws on some of these. I've been experimenting rather than the ones that came with them. I couldn't remember if they were long enough, but they are. Or not. No. That needs a longer screw, which I'll swap later, but as for the general arrangement, you can see what that is. That fits on it was the front rail of the printer, it's now the back. And the tool head then mounts to there when it's parked. That height's offset and distance offset the height offset means it's exactly the right height for my made up tool carriage, and the offset front to back is to match the rather bigger Hemera direct tool, which has a much smaller offset. So this is to bring the tools all in line at the front, so the tool head isn't trying to go between them and colliding. does unfortunately reduce the printing area a bit, but it's an experiment. It's just a proof of concept that a fairly straightforward, not exactly basic, but conventional, should I say, printer like the X5SA Pro can be adapted for Toolchanger. Now, I think the same setup would work exactly the same on the bigger versions, the 400 or 500 versions. I will do another short video of this once I get some connectors, because I don't know the connectors yet, and get this cabled up and fitted to the machine. But that's it for now, and hope that you enjoyed it with some use. Right, that was not the end. I forgot about unboxing the Hemera extruder. It's the bowden version, so I've got a direct drive version on the machine. Oh, and I also need to apologise, there were 4 screws for the fans, just 2 of them had rolled under something else on the desk. So just unseal this box and open it up, see what's in it. Okay, and I can get into it. Oh, there we go. The sleeve is a very tight fit. In the box. That's a heavy one. I'm guessing that's the motor. It is. A complete extruder, in fact. Multiple warnings on the box about using the right length screws, because there are captive nuts in the little casting slots in the motor. If you try and put a too long a screw in, it's going to just act as a jack, pull the nut away from the motor body and take the outer part of the casting with it. So be careful of the screws. Okay, so what's in this one? This is sealed. Shame to cut the logo, but anyway. Another one there, just in case. It's just got the extension cables and yes, another set of Allen keys. I see, that's got a piece that screws in instead of the adapter for the direct piece. There's an adapter for a bowden fitting, which fits instead. So screw that in, nip it up. It's already got a collet in the top, collet in the bottom adapter, and there's one retaining clip there. Okay, and a set of mounting screws and the little square captive nuts. I've got to design or find a printable mount for this. I'll just pull all the bits out of the bag. There's a couple of grub screws. Oh, it says Hermes on it rather than Hemera. Anyway, a couple of grub screws and some nuts. I was saying the nuts, there are some pre-fitted on the drive side of the extruder. But for the other side, they just fit in the square nuts fit in the slots, and then that will allow an M3 screw to go in but not very far. That's about it. Any further and it will start breaking things. There's 5 nuts, so there's one for each existing open slot down the spare. No fan. Surprised about that. That needs a 40mm fan. Or it can take a 40mm fan. There's a pair of soft tapping screws to attach one. It possibly doesn't need it as it's going to be an open air and not above a hot extruder, or hot end. But I'll probably fit one anyway. Now, I'm using 2 V6s on the machine. One with that and one with the original Titan extruder that came with it. So I'm also going to fit that. Now that's got some adapters to fit onto a frame somewhere already, and it's got a filament out sensor as well, which I may connect in. But the Titan extruder is quite good. E3D recommend these; they sell them as well. And I'll in future see how the two compare. It looks to be a pretty similar motor. Yeah, it's about the same size motor, but it's obviously a different one. This hasn't got the captive nut positions in the frame, which the Hemera one has. I don't know if there's any specifications, but I think the basic thing is this has a reduction gear. I'm not sure if the Titan does or not, if that's direct. Oh yes, obviously it does have a reduction gear, it's visible. Yeah, it's a very big gear. Should look before I speak. Yeah, so that's got a quite high reduction ratio from the motor shaft with a little brass gear to the extruder drive gear, and then down to the hobbed shaft in the middle. Anyway, once they're on, I'll be able to try them both and see how the two work. Yes, you get a nice long cable with it for the motor, which can be joined or adapted or whatever. That's going to go into one of the CANBUS toolboards for the Duet controller. Right, I'll just pause for a second and go and grab one of those to show you. Okay, this is an E3D toolboard, a little tiny thing. It's actually designed so it will fit directly on the side of an Hemera extruder. Just some nylon spacers and put it on 4 of the mounting holes. It's very convenient. So the stepper motor cable is going to be about 2 or 3 inches long, just to loop round to the stepper motor output on this. In fact, I think that's it. Or is it that one? Somewhere there's a stepper motor output on here. It's got connectivity for such as a tool probe or a Z probe, the heater on those 2 terminals there. That's 24 volt power in on the big connector there, and they do come with a full connector kit. There's a couple of switch inputs, 2 fan outputs, and the entire connection back to the control board, the Duet main board, is 24 power, and a CANBUS link on, which can just be a thin twisted pair. There's actually a loop through to avoid echoes on long cables. The whole thing should be one long daisy chain, so it goes in and out of each board. So it's just a little 4-pin connector there, and that's the entire signal, rather than having what we've got. This has got about over 20 connections on it, rather than 20 wires back to the main board from wherever. And you've got 4 thin wires and a power connection, which makes the overall assembly very neat. As I say, these are version 1.0. The latest one out of version 1.1 has provision for a little switch on there as well. So if it's mounted on a direct extruder, when that's fitted in, it senses when the tool's in the dock, so it can tell which tool is loaded and which isn't. If the thing's been powered off, it can check all the tools are put away before it tries to do anything and has a collision anywhere. So a nice, neat little system. Whichever way around it goes, it's just a square fitting.